everyone, and welcome to the Internet Society workshop on Introduction to Routing Security and MANRS. I'm really happy to have you all in this group today. And today's speaker is Mr. Naveen Lakshman. He is actually a MANRS training fellow and solutions architect at Graphite Networks based in Ernakulam, Kerala. His expertise includes planning, designing, and implementation for IPv6, SD-WAN, SDN solutions for enterprise SMB customers. He assists customers in pre-sales consulting, migration, and setting up proof of concept. He's an active participant at SENOC, Apricot, ENOC, ICANN, and IETF. He has served as a program committee member for SENOC, ENOC, Apricot, and APRX. I welcome Mr. Naveen. The space is yours.
Yeah, thanks, ma'am. So, just let me give you a brief introduction about the session. So, this is like this is a workshop session, so it's not a webinar. So it means that you have to be interactive. You have to interrupt me at times. You have to ask questions. I'll be asking questions. You have to respond. That's how it works out. And moreover, the session would be around 120 plus minutes. That's 2+ hours with possibly a break in between. Let's see how it goes. And it's raining in Kerala, so at times I might break off. It means that you should allow me a couple of minutes before I switch on to another, possibly my mobile hotspot. So that's an advanced excuse I'm asking for. So the agenda for the day would be like, I would give you a brief introduction on what a BGP is, about a gateway protocol, and something about routing security and possible solutions, and what is MANRS, and what are the MANRS actions, and what is MANRS rover status, and what is observatory, and some hands-on language. So, internet terms, how do you define a network operator? An organization that is running an IP backbone is called a network operator. Sometimes you call it as a service provider or a network provider. So and at times it provides access to end devices and other networks. So examples for that are Airtel, Vodafone, AT&T, NTT, Telstra, you name. Most of the providers come under the network operators. So, and you have another category of networks, which is the research and education networks, which provides access for universities and colleges. And you can see names of that are ERNET, National Knowledge Network, EPAN, Internet 2, PERN in Pakistan, etc. Then you have Internet Exchange Point. Those are the locations where companies like ISPs and research and education networks, cloud and content providers exchange internet traffic. So Nixie, DKIX, BharatIX, XTMIX, etc. are defined as an IX. So what is BGP? So my question is, have you ever heard about the term BGP in your life?
Yes,
Can you see my slide?
Yes, sir.
Yeah, fine, great. So fine. Yeah. So have you heard about the terms BGP, or have you ever configured BGP? No. How many? Yes. No. So how many of you have configured BGP in your real life? At least heard about BGP, or I haven't configured. So use the chat if at all, or you can open up the speaker. Open up your mic and speak up. No. Anyone has configured BGP? Haven't configured. So anyone, need one person who has done it. So not even one. Okay. Okay, fine. And let me mute who someone is making background noise. So. Okay, fine. So BGP is the only protocol that is used in the internet. So as of now, there are around 71,000 BGP AS numbers, operators interconnected using a protocol that is called BGP. So this is the only protocol you might see it in the internet. And this is the protocol that is used for exchanging routing informations, or like V4 and V6 between networks. So it is classified under an exterior gateway protocol. So I was expecting someone, an audience with some background on routing protocol. So technically, an EBGP exterior gateway protocol is used for routing between That's how it works out. And this is the only protocol that is used for exterior gateway. And it runs on top of TCP, which is and it uses port 179 for communication. Okay, fine. So, and you have to have a TCP session established between two speakers before they start a BGP session, and they need to be physically reachable. They need to be logically reachable between each other. So, and BGP is a path vector routing protocol, and I'll tell you what a path vector is. And it sends incremental updates, and it is used in internet backbones, exchange points, telcos, and large enterprises. Okay, fine, no issues. So what is a path vector? So BGP is a kind of a protocol that that lists out the list of path it has traversed. Say example, as example, take a route 192.168.1.0/24, and you can see that it lists out some numbers, right? I'll show you what those once you start doing the labs. And these are the list of ASs or the BGP AS numbers or the BGP numbers in simple terms that a route traverses to reach a particular destination. So this is the originator of the route originating AS 112.68, and it passes and it traverses to 6337, 7018, and 6461. That's how it goes out. So that is the reason BGP is called a path vector routing protocol. So let me admit. And there are two types of BGP. One is internal BGP and external BGP. So internal BGP is, external BGP is used for exchanging routes between two ASs, meaning that if Airtel wants to exchange prefixes with Reliance Communication or Reliance Jio, it has to use external BGP. Or technically, normal when you say BGP, it is external BGP. So inside your operator's network or a data center or a telco networks, you would be running iBGP as well. So that is used for carrying your customer prefixes or internet prefixes within the backbone. So before we go out, let's see what a BGP session is like. So you have a network like this. Say example, BGP is identified with a unique identifier called the AS numbers. So in this particular case, you are running AS200, and you have two external connections. One is connected to BGP AS100, and other is connected to BGP AS300. So the relation or the BGP relation between two different ASs is called external BGP. So that is the eBGP. Okay. So you have two eBGP connections for AS200, and you have iBGP connection if you are running BGP inside your network, that is AS200, and the relation between all these three routers within the AS will be called an iBGP session. Okay, and I'm skipping the message tab because it might be a little bit too much technical. So BGP is identified with an autonomous system number. So it is what is an autonomous system? It's a logical grouping or of a particular network, and it is identified with a number, and this is allocated. This number is allocated by the regional internet registry or the national internet registry or the upstream ISPs from where you might request for a BGP session. As of on 5th, you have around 7,958 BGP ASs around the world. So you can see the list of assignments in IANA.org, assignments AS numbers. And this is the list of BGP AS numbers. You have a 16-bit AS number and you have 32-bit AS number. So earlier, when BGP was designed, they didn't expect this to be, the internet to go as it is now. So they came out with the 16-bit range alone. So then later on, the IETF understood that it's not going to work out. And they started, planning out for 32-bit AS number, which is in RFC 6793. So as of now, you can see the AS0 and AS65535 is reserved, and 126464495 is public internet, and you have a certain set of BGP ASs for documentation, private use, transition AS, and documentation. And in this 32-bit range, it starts from 6555 to some huge value. And from 4 to some 000, it is again a private range. The ones in the blue are the ones you might be visibly seeing. So meaning that when I say 71,958, it would be from this particular range of BGP AS numbers. So that is the example. For 16-bit AS number, you can see AS 710075, which is fiber at home Bangladesh. And 32-bit AS number is 138754 for Kerala Vision broadband. So that is a 16 and a 32-bit range. So in terms of BGP configuration, it is like pretty straightforward. You just go under the router BGP and the AS number, because I'm configuring router B, which is this one, the left one in AS200. And okay. So router B is like something which is configured with BGP 200 for external, which is it's connecting to AS100. So the configuration would be in the neighbor's IP address, remote AS, and 100. Okay, so and go to the address family because it's a V4 connectivity. Go and activate the particular neighbor. That's it. For iBGP, that is for if you run BGP inside your network and you want to run BGP and form neighborship between routers inside your AS, you would go under the router BGP 200 and you issue the neighbor command with the same AS number. So the configuration is the same. All that matters is if it is between two ASs, the remote AS would be a different AS, and if it is between if it is an iBGP, it is the same AS that is that you are pairing with. So BGP AS types. BGP AS type, it's a stub AS is like if it is a single homed or if you are connected to one upstream provider. So in that particular case, you call it as a stub. Okay, fine. And multi-home is when when your network is connected to multiple ISPs, because you have more than one ISP connected. You call it multi-home. Transit is when you want to connect to another network, but you don't have direct connections to them. You buy transit from another large ISPs like NTT, AT&T, etc. Tata Communications are examples of transit providers. IXPs is the place where most of the internet, most of the network operators and content delivery networks, education and research network, or smaller ISPs paired with each other so that they keep the local traffic local, and the exchange prefixes that are supposed to be localized. So, a customer network would be something like this, because as a customer, you might you want to reach the internet, you might have to get a transit from a large transit provider. So for a customer running BGP, you could either get a default route. I'll show you what a default route when I start doing the labs. You might get a default because you want to reach the rest of the internet, but unfortunately, your resources on the edge devices at your place is not supporting. All the BGP routes. What you can do is like you can appoint a default route to the transit provider. So the transit has the complete view of the internet. It has the complete routes V4 and V6, so that you can reach the transit. So the transit has reachability to the rest of the internet. Thereon you can reach there. And what a transit does is like it also advertises the customer prefixes, which I'll show you once we start understanding how we publish networks in BGP and start sending to the upstreams. So downstream is like it is like you receive. Okay, it's something the same thing I said. And then the problem. So as I told you earlier itself. Okay, do you have any questions for now? Do you have any questions? Because let's go back and try to check if you have any questions, because is it clear with you guys? I'm scrolling through the slides so that you have any questions, you can point it out. A default route is when you don't have any particular destination and you just want to push packet to anywhere you want. That is what you put a default route, meaning that if I want to have a particular destination, then I put a static route or publish it in BGP. But if you don't have any any particular network to reach out, you put a default route pointing to the transit or your upstream. Okay, that is the case. You do a default. I'll show you how it is because on the dashboard, I'm just go and show you what a default route is. Might be a little bit slow because so if I give the command show IP BGP, you can see that a default route is okay, some issues is there. Let me just restart my labs because we were doing the labs couple of days. So this is the default route. Okay, so if you want to reach the rest of the network, you point a default route to the next hop. The next hop is your 203.0.113.251. In this particular case, it's the peer you're having getting a default route. So the peer is announcing your default route in BGP. So that route default route gets propagated to your network. So if you want to reach to any network in Yes. I'll give you the lab access just because someone asked me something, right? I just want to show it to him what it is. So the default would be pointing to the peer, but we have to. It is not the one that's supposed to send you the default. So we'll fix it out as we progress. So other than that, any other questions?
If you have any question, you can just unmute and talk or you can post in the chat.
So my question is actually related to SDN. Does SDN also uses BGP?
You are asking SDN uses BGP?
Yeah.
Yeah, you can use anything. You can use BGP in anywhere.
So
the point of
new developments that BGP will be replaced with some other protocols in coming.
I don't think so because it's running good as of now. There's no point in doing it. But what is the point in bringing something? Because most of the work of the protocol development is done at the ITF, and they are improving lots of stuffs in BGP. So that so it has been working, I think, from 81 onwards. So it's doing fine. Other than some leakages and hijacks, everything works fine with BGP as of now. So I had a power outage. I just had to switch on providers. So the problem statement is like, as I told you earlier, it's like, so BGP is just used for exchanging routes. So the problem is the BGP is not built with security. It doesn't know what kind of routes your customers are sending or your peers or your transit is sending to you. So sometimes there might be incidents where some networks would be leaking some prefixes which are not supposed to be leaked by them, or someone is hijacking your prefix. So those kind of incidents do come on a daily basis, and there's not a single day without without a routing incident, as of my knowledge. So every day you have issues. You can check BGP stream. You can see every day there is some kind of issue, whether it's a leakage or a hijack or outage, anything. So these are the list of recent incidents which happened on 31st of July, last week. So VIT Communications Global, it's based up in Philippines. They just leak around 167,485 prefixes. And it affected over 9,759 BGP speaking ASs in around 193 countries. And what made this issue is like they're connected to two providers. One happens to be Hutchison. I don't know which AS number is Hutchison. They're connected one to Hutch. Another provider is another AS number. So what they did is like they started leaking routes of one provider to another provider. So it is not supposed to be in that way, because from the customer, a provider to provider leaks never happen. I mean, it normally doesn't happen like in the normal case. But in this particular case, a provider leaks its prefixes, the list of prefixes it had through VIT communications, and VIT gave it to its upstream. So it started leaking, and you see the spike of traffic in this particular graph. And the recent Vodafone incident that happened, I guess it was on April 16th. Vodafone started originating 31,000 prefixes, which they don't belong. And there were like 40,000, 4,000 prefixes, which were ROVA assigned or RPK assigned. And it leads to Bharti Airtel and Vodafone UK, and it propagates to Hurricane as well. So prefixes like for Google, Microsoft, Akamai, Cloudflare, etc. were affected. So that was a case of hijack. So this was just a couple of incidents, and if you go to bgpstream.com, you can see lots of incidents on a daily basis. So around the globe, they detect incidents like hijacks or prefix leakages. So routing incidents cause real-world problems. Three main problems you might see in your networks is prefix hijacking, route leaks, and IP address spoofing. So prefix hijacking and route leaks are related to BGP, and IP address spoofing is not related to BGP. It's your V4 and V6. So route hijacking is a process when some operator or an attacker says that I am another operator and starts advertising the particular prefixes one operator has. The common example or the common example is the most famous example is the 2008 YouTube hijack, where YouTube prefixes were hijacked by Pakistan Telecoms. So how do you fix it? We'll show you how do you fix it while filtering. Okay, fine. So just trying to understand the routing incident. On 24th February 2008, YouTube having its AS number 36561 65. And Pakistan Telecoms during that time has asked YouTube to bring down a particular Pakistan Telecoms to put a null route. So what they did is like they started advertising more specifics. So /22. The /22 is the prefix YouTube owned, and it started at Pakistan Telecom started advertising at /24s, and their upstream is PCCW Global started propagating the announcement, and the rest of the internet started getting the global routing table started getting a /24 entry of the prefix which YouTube holds. So most of the traffic got rerouted to that /24 prefix length, and it was nothing but Pakistan Telecoms trying to hijack it. So meanwhile, YouTube started announcing a /24s. Now we have two /24s in the global routing table. Now what BGP does is like, if you have the same length of prefixes, it would go for the shortest AS path. So the one with at least in the Asia Pacific, because PCCW Global now is a tier 1 provider. It was in 2008, they were like regional backbone. So they had lots of regional connectivities. They started the networks in the users in Asia Pacific a few of them got rerouted to to Pakistan, and the rest got to the right YouTube itself. Meanwhile, what happened is like YouTube started advertising more specifics, that is /25s into the global routing system, two /25s. Now again, the longest prefix match means So by default, BGP does two things. One is like if you have a longest prefix match, it would take that into the consideration and route traffic to that particular destination. Or if you have two if you have prefixes with the same length, then the shortest AS path would be the best option. Now, again, what happens is like PCCW Global would withdraw the routes which Pakistan Telecoms has done. And to an extent, the hijack was mitigated. So that's when the routing incidents or the BGP insecurity started discussing about the BGP routing, insecurity of BGP. So on a daily basis, you can see lots of hijacks going around. So this is one example, Bharti Airtel, which owns 106.193.255.0/24, which is supposed to be announced by 45609, has been announced by someone else, by CNNIC, which is in China. So here the same prefix hijack happened because again 106.193.255.0 and the same prefix was hijacked by CNNIC and China. You can go to the BGP stream, you can see the incident and the play, how the traffic got rerouted. Yeah, I'll be sharing the slides because I didn't get the list of participants, otherwise I would have shared the slides right away. Another route leak is like, so this is when someone leaks. So say example, you have two customers. This is the lab topology you're going to work out. So you have two customers, both of them are multi-home. In this particular customer case, this is multi-home. This particular customer 64501, and you have another customer 64502. So customer 502 has to reach google.com. So the best path to google.com was through the center one, that is 64500. But unfortunately, what happens is like the multi-home customer over here in the left started saying that I have the best path to Google, which is not the optimal path to reach Google. But unfortunately, BGP does what it does is like it takes the traffic back through AS64501 and through another transit provider. So this is a classic case of leakages. And so leakages do happen if you accidentally, it is most probably the accidental configuration. So if you test some softwares like optimizers, you might leak some more specifics and you might reroute the traffic into through another network, which is not supposed to be. So the classic case of this is a case of where 112.198.30.0/24, which is owned by Wipro Spectrumite, was leaked by Globe Telecoms, having an AS number 4557, and it leaked to Telstar Hong Kong, and it was detected by BGP system. So this is a case of leak. So incidents in Asia Pacific, and I just listed it out because May, June, you had incidents like Bharti Airtel's announced by CNNIC, which is the same prefix, the wrong AS advertised by wrong AS advertising a prefix. Most of the cases, it's wrong AS doing it, or it is a longer prefix. That is, more specific is announced. So in this particular case, Africa has announced 156.241.0.0/16. But unfortunately, Galaxy Broadband Pakistan announced a more specific of that 16, so that the traffic is rerouted. So it is either accidental or some issues or fat fingers. And AT&T is a prefix of 172/12 was hijacked by controller's data center in Hyderabad. So 54 of that slash. Regionally specific because and leaks you might see in Asia Pacific. So you see Sunny Valley's a prefix got leaked by Globe Telecoms, and which got leaked to Vodafone Europe and Telstra and Flag Telecoms and Korea Telecoms, etc. So these are the few leaks I pointed out. And because I was doing a session on at the APAN, so we had to pull in the research and education networks. So BGP hijacks on education networks, that is like in India, you have ERNET, Education Research Networks, and National Knowledge Networks are research and education networks. So you can see most of the networks are have implemented MANRS and API for protecting the routing security, infrastructure. But still, the ones who missed out are the ones who get affected. So you can see NCREN's prefix has been hijacked by Optus, which is based up in Singapore, Australia. So again, they announced more specific /22s from the /16s. And as you go down, you can see that even your V6 prefix is not spared. You see the prefix of 2001:2 F8 1002::/48, which is part of Cynet Japan, being announced by some telecom provider in Brazil. So it can be the same prefix, it can be more specifics, or it can be a wrong AS doing the hijacks. So how do you do? How do you fix it out? Or what tools do you have? So you can do prefix or AS path filtering. You can implement RPKI, which is a resource public infrastructure. You have internet routing registry toolset, or you have IRR power tools, and you have BGP Q3 and Q4, which we might see in a couple of minutes. And you can see BGP sec as well. So the problem is it's not implemented. Not much of the networks have started implementing it. So you had now I discussed about the problem statement. So what is the solution? Questions? Any questions? Any questions? I'm going back to the slides. Any questions? Any questions? See, I don't know. Let me see if I have. So it can be intentional. So I don't have friends from neighboring countries. So it can be intentional, as I told you in the case of Parktels, because it was the regulator who pulled up the telecom provider and asked them to put an route or take it out. So in this particular case, it was a regulator thing. But most of the cases, it is accidental, because I don't know whether you come from the networking background. So most of the configurations are done by L1 or L2 engineers who don't understand how things work. So what they do is like they would copy paste it. They might do the wrong configuration. 8 might be they put it as 0, or 1 might be like 7. So whatever it is, sometimes it's unintentional, and there's no way to identify whether that it was done purposefully. So other than that, there's no way to understand whether it was for a purpose or not. So no questions. Then we take, okay, what else was the comment? Security bring delay, with it how to overcome. Security bring delay. Can you just clarify it, or open up your microphone and just tell me what it is? Mohit? No. See, latency is nothing, because you have gigs of traffic and you bandwidth for the providers. And it's better to do something than nothing, right? Because if someone is hijacking your prefix and your service is disrupted, what's the point in talking about latency and delay? The service is not available, then should you bother about it? So MANRS is an initiative by the Internet Society. So I don't know whether you come from the Internet Society. You know what Internet Society is. So Internet Society is a not-for-profit organization which does lots of good stuff on networking for the internet. And so MANRS is an initiative that is supported by Internet Society, but it is a global connective measure that has been adopted by multiple service providers, Internet Exchange Point, research and education network. So this, to an extent, brings it can fix lots of things that are related to routing incidents. It cannot stop completely. I'll tell you, as the session progresses, you will understand how that works. But you cannot fix everything, but to an extent, you can bring some control to the routing incidents. So there are 3 programs for it. MANRS is initiative or MANRS actions, you call it. There are 3 programs. One is for the network operators that are like internet, internet service providers, or research and education network comes under the network operators. And you have internet exchange points, MANRS for internet exchange point. Example, like if National Internet Exchange of India, NIXI, or Bharat IX, or Euro IX, or Extreme IX, etc. If they want to come to MANRS, they can join the IX program. And for the cloud providers and content delivery networks, so Amazon, Google, etc., Netflix are part of this program. So we'll be talking more about the network operators. That's where I belong. So it was started in 2014, like a long way. And there are 4 actions which is defined and which is called the MANRS action. The action 1 is filtering. So filtering is like you prevent propagation of incorrect routing information. We'll talk about it in depth, what filtering is. So you have to ensure that you announce your correct prefixes or IPv4 IP prefixes from your customer and your networks to the rest of the internet. Okay. So, and also you filter what your upstream sends to you. You don't want to send any kind of hijack routes or anything that is called bogans or shouldn't be routed into your network, or you shouldn't be propagating it. And there is something called anti-spoofing, that is action 2, which prevents traffic from spoofed IP addresses. So we have to ensure that a source address is validated, at least for a single home network, so that it is not being part of any spoofing activity. And the action 3 is global coordination, meaning that the network operator should be having what you call the globally accessible contact information in the routing databases, so that if you are part of any routing incident, someone can reach out and tell you what the issue is and work together and start fixing it out. And the other thing is, the last action is the global validation, where you facilitate validation of your routing information on a global scale, meaning that you publish it in an internet routing registry, or you publish, you implement RPK to validate your routes. So those are the 4 actions. And action 1, 3, and 4 are mandatory for network operators, and action 2, anti-spoofing, is not mandatory. So let me show you what those things are. So you can see that if you're a network operator and you want to sign up for the program, what it does is, like, you have to implement all these. Let me show you, just populating it. So you can see, say example, so RNet is an educational network based up in Australia. So you can see their AS number is 7575. So the country code, and they have implemented the actions. So if you're a network operator, you have to talk to the MANRS team, and they would help you out in fixing up the filtering, test whether you are doing anti-spoofing, and they'll check whether you have implemented properly, updated the global coordination, which includes your contact information at the IRR regional internet databases and whois database. And they'll check for whether you have validated in the IR internet routing registry as well as the RPK. So this is this is the MANRS action for network operators. For the internet exchange point, you have 5 actions. So one is prevent incorrect routing information. Second is to promote MANRS to the IXP membership. So say example, if an IXP in India has implemented MANRS or adopted MANRS, they have to promote the MANRS to the participants who connect in the particular internet exchange point. Then they have to protect the peering platform from sending some unwanted traffics, like they have to filter out protocols like CDP, etc. So again, they have to facilitate global coordination, and they have to provide monitoring tools. For the internet exchange point, it is pretty simple. They have to publish the routing, the routing information in internet routing registries and implement RPK. So action 1 and 2 is mandatory for them. 3, 4, 5 is optional. So CDN programs was pretty new. It started last year, so they have lots, which is not, we shouldn't be bothered with because we don't have anyone from the CDNs. For them, it's more strict. The plans are, the action plans are a little more stricter than the rest of them. These are the plans if you are a CDN providers. So as of now, if you are not from the networking, from an operator background, you don't need to think about MANRS. All you need, if you're coming from an enterprise network, you can ask your upstream service provider through which you connect to implement MANRS. That's what you can do. If you're a college or a university, if you're connected to the National Knowledge Network or the Education Research Network, you can ask them to implement MANRS on their networks. So that can protect you. That's enough. It is purely for ISPs or network operators or internet exchange points or content and delivery networks. So we will be talking about more on filtering. So this is documented in RFC 19, RFC 7454. So it lists out the list of filtering mechanisms. So imagine this is a network, a reference operator network, and we'll be doing labs based on this. So imagine you are on AS 64500. So you want to be a MANRS participant, and you're connected to a transit provider. So transit provider is used to connect to the rest of the internet, and you're peering with another network provider which is having an AS 64511. So it's a peer, and you have a transit from 64510. Okay, fine. And you have single home customers downstream. On the left is AS64501 and AS64502. Okay. The reference operator in network infrastructure is a dual stack. Dual stack meaning that you have V4 and V6. So you are originating or announcing V4 and V6 to the transit or to the peer as well. Okay, fine. Okay, fine. So how many of you have any idea about IPv6? So do you know what IPv6? You can understand IPv6 address? Yes. So if anyone is new to IPv6, if you don't know what IPv6 is, okay, fine. So because our infrastructure is running on, the labs are running on V4 and V6. But again, if you don't know V6, you can at least do on labs on V4. So this is the operator network. Just try to understand, take a couple of minutes to try to understand it, because whatever references I would say will be based on this particular diagram. So again, I'm trying to explain it. You are having an AS number 64500 and you are planning to implement or adopt MANRS on your network, meaning that you're going to implement all the 4 MANRS actions so that you don't propagate any unwanted routing informations. You're going to implement anti-spam, anti-spoofing techniques. You're going to implement global coordination, and you're going to implement, you're going to adopt, update your routes in the IRR or RPK report. What is this? Okay, at least you have that idea. So again, the point is you are connected to a transit provider, you have a peer, you have 2 single home stub customers. Stub customer meaning that they don't have any other networks. It's just single connected to an upstream provider. So at least you have an idea, right? So I would be referencing to this particular diagram. So why do you want to filter? So as I told you earlier itself, most of the threats, at least it is, because the problem is that if you are running BGP, you can announce anything, meaning that you can use the network statement to announce anything you want, and you can accept any prefix. So if I want to hijack, say example, if Google's DNS is, global cache is 8.8.8. If I announce 8.8.8, what happens is like my upstream, if they don't implement filters, they would accept it, they would propagate. If someone's trying to cache on 8.8.8, they would be redirected to me. So that is the problem with BGP. So there is no built-in check mechanism to check whether the routing announcement received from a particular BGP speaker is legitimate or not. So filtering is one of the first level line of defense. What the problem is, you as a network provider know what you are announcing to the rest of the internet, but you have no control of what other networks announce to you. Because as in the diagram, you are a managed participant, and you know these are the networks you're going to announce, meaning that you are announcing 203 0.113.0/24 and IPv4, and your customer prefixes as well, 192 2.0/24 and 198.51.100.0/24. So these are the three IPv4 prefixes you would be sending to your or announcing or advertising to through BGP to your transit or your P. Okay. And 2001 DB 8000 ::36 and 1001 ::48, 2002 ::48 are the three IPv6 prefixes which you as a managed participant would be announcing to the transit or to the peer. So other than that, you know, yeah, unless and until you unless and filters, what happens, like someone would be saying perfect or leaked routes, which you accept, propagate to your customer or to your peer. So the problem is you have to implement filters to stop propagation of unwanted. So you have to avoid issues, you have to decide what routes to accept from other networks. So the filtering procedure is put up in manners.org, ISPs /guide filtering. Check it out. So there are two types of filters you have to understand. One is outbound filter. Outbound filter is for applying to your transit, to your peer and your customers. Okay, that is what you send outside. It's an outbound filter. Inbound is like what you receive from them. So what you receive from your customer, 64501, 6402, 64511, which is your peer, and 64510, which is your transit. So those are inbound filters. So you have to make sure that you create proper filters and you filter what is required and I mean you what is required and filter the rest. So for outbound filtering, so the configuration should be like you should only send your network or your downstream customers network. I'm going back to the slide. I mean to the diagram. It says that if I do outbound and I have to map, that is my that 03.0.113.0 and 192.0.2.0/150 198.51.100.0. Only these three prefixes should be sent out. Okay. For V6, the ones 36, 48. Other than that, you shouldn't be sending it. And you shouldn't be sending any globally not routable routes as well. Say example, RFC 1918 prefixes like 10 series, 172 series, 198 series, and 192 series, sending it out. Those are, you shouldn't be sending them to your upstream or to your peer. Okay. And that you can send it on /24, so 48 will show it, and the labs will try to understand it. Because it's a best practice that you don't send anything beyond that. /24 or 25, I mean /25, 26, those kind of things are not allowed in the global routing system. A default, if your upstream is looking for a default, you can send it, but your transit won't accept a default from you because the transit has the rest of the internet, right? They have the complete routing table. They won't accept a default from. Again, which we'll look into that. Outbound filters. This is like outbound filters. So to the downstream, downstream in the sense that this is your downstream. To the customers, you can send a default route because for the customer, they have to, if they want to reach some network, they have to reach to you, right? So you can put a default route to the downstream, and you can, if they have larger capacity routers, you can send the complete routing table, or or you can just filter out what you call the default and the bogans, which is like special use case addresses and unassigned address box and RFC 1980 address box. So this is for the customer downstream, which again, when we start doing the labs, we'll come back and start fixing it out. To the peers, that is your right side. The peer, you should be sending only your prefix and your customer's prefix. Okay. You're going to send lots of mails regarding what you send, because peering meaning that your local traffic stays local. So most of the network operation to the customer, you can put a default or the complete routing table based upon what your customer is expecting. To the peer, you can send your prefix or your downstream customer plus your downstream customers, or what you have agreed to send on. To the upstream, only your prefix and your downstream customer prefixes. So these are the outbound filters. Any questions on the outbound filter? Are you getting it, or is it too much technical? I don't know.
No, sir, no.
Yeah, it is simple as you do the labs. Okay, fine. Because it's purely theory, it might be a little bit tricky, but let's once you start doing the demos, you'll get what I try to convey. So outbound, crystal clear. Inbound is the problem, because as I told you earlier, you are a nice person running your network, you know what you're going to send out, but you can't expect a neighbor to be as good as you. So they might send bogan ASS in the meaning that if I showed you in the earlier slide that there are few publicly available ASS which should be seen in the AS path. There are cases when someone is using wrong ASS, bogan ASS to advertise a particular prefix. So you shouldn't be accepting that from the inbound. You shouldn't be accepting bogan routes or bogan prefixes from your upstream or your peers. You should be filtering out RFC 1918 address space, IETF benchmarking. You should be removing shared address space which starts with 100.0.0, 100. something, and you have to filter it out 169, which is APIPA. You have to filter it out 127, that is your loopback address. Those kind of things has to be filtered, because those are routes which you shouldn't be receiving from your peer or your upstream. And you shouldn't accept any your own prefix. Just imagine this is your prefix. Say example, this is your prefix. 203 is your prefix, and somehow a transit is giving you the same prefix, meaning that he's learning a network from some source, which happens to be you. So it means that your network is hijacked somewhere. So you shouldn't be accepting your prefix inbound as well. So that is how you plan a bell plan filter. And don't accept a default unless you requested for it, because if you are looking for the whole routing table, there's no point in requesting for a default. You can filter out the default as well. And don't accept prefixes that are too specific, because meaning that if someone is advertising a /26 or 25, even if they send to you, just ignore it, because you keep a boundary of /24. If it is too much AS path, a long AS path should be filtered, and you can create filters based upon internet routing register, which I'll talk about in the coming slides. These are your inbound, which you can plan. So from the customer, meaning that going back to the diagram, from the customer, because your customers 64501 and 64502 are sending two prefixes, 192.0.2.0/24 and 198.5100.0/24 in V4, and 1001:48 and 2002:48 in V6. So these are the two prefixes your customer would be sending it to you, so that you would be receiving it as an inbound. So when you plan your inbound, what you do is like you check whether that particular prefix is part of your assignment, then it's okay, it is, because in this particular case, you can see your prefix is 1000::36 and one of your customer is 1001::48. It means that it has been allocated from your block. Okay, so it is clear that it is part of your parent block. So you're allocated to the sub-allocated to the customer. It's okay. So in this particular case, it's 2002 is a block which is not part of your network block. So you have to do a check whether he is eligible to announce that prefix. So you do who is on that particular prefix and try to understand who that prefix holder is before you start accepting that routes from that particular prefix, from that neighbor. So the inbound filter, so for this particular example, that is customer one, the one in the left, right? So customer 64501, the prefix is something like this. The downstream customer has a prefix of 192.0.2.0/24 and 1001::48. So there are two prefixes. First, you create a prefix list with the syntax is IP prefix list and the name of the prefix list. In this particular case, I use the AS number -customer V4. So I can understand it's a V4 prefix list for this particular customer. Then I match a permit, I use the permit statement and I match the particular prefix which I want to allow or accept. I put the prefix over here and the length of the prefix, and I deny the rest of the prefixes. So once you do the labs, you can see that your customer is sending lots of unwanted routes to you as well. So you can filter it out using this prefix list. So allow only a customer prefix, you're going to deny the rest of it. So V4, that's for your V4. And for V6, again, you create a prefix list for it and you filter, you permit only the prefix that your customer is supposed to send and you deny the rest. Now the prefix list are good to go, and now we have to implement on BGP. So go to the BGP router BGP 64500, go to the corresponding address family V4 and V6 and call the prefix list, implement the prefix list inbound. Okay, and just clear the session. So what happens now is, like, if your customer is sending lots of other prefixes to you, in this particular lab session, you can see that your customer might be sending more than the prefix that they're supposed to send. What happens now is, like, whenever a BGP router is received, right, it checks for a filter, the filter which says that it has to allow only the networks 192.0.2.0. Other than that, anything that is received from the neighbor is filtered out. So this is the clean inbound filter for customer. So this is one customer. The other customer, you need to do the same thing. If a customer is announcing more than one routes, you can create multiple prefix lists for that. And by the end of the day, issue the deny statement so that the rest of the prefixes, if they're sending, is denied. So this is clean inbound from customer. And from the peer, the peer problem is, like, you exchange peer. It might be a little bit tricky when it comes to peer, and you have to look for. You can't manually do it because there'll be lots of prefixes that your peer might send you. So you can use tools like BGP Q3, Q4, etc. for creating the prefix. This is simple because customer prefixes are very less. When it comes from peers or transit, it will be like lots of prefixes. So I can use the tools like BGP Q3 or Q4 to generate filters. So from your peer, you have, most probably they would be exchanging lots of mails and regarding what kind of prefixes they would be sending. So possibly you send your prefix and your downstream customers, and possibly from your peer, their prefix and their downstream customers, if they have another downstream, their downstream as well is being sent. And verify whether they are the authority to announce this particular route and their prefixes and their customers, and don't accept anything larger than /24 or 48. So that is how the inbound from the peer. That is, peer is in the right side in this diagram. Okay, so don't accept anything other than what they are intended to send. In this example, there's no V4 routes from the peer. So 2001 DB8 3000::36 is what your peer announces to you. So you're not going to accept any V4 routes from that. But in our lab environment, I think we have a couple of V4 routes from peer, which shouldn't be seen by you, right? So you have to filter it out. So inbound, you have to filter it out. And from your side, what you send outside, it's is like you send this particular prefixes. Okay, so you send mails that, okay, I'm having these set of prefixes, I'm going to send this. So he'll say that I have, this is my prefix, or I have lots of customers behind me. These are the prefixes I would send you. So that is, so that you can plan your inbound filters so that their customers are not filtered out. So that is your inbound from the peer. So this is how it works. If, say, example, your peer is having a prefix of : 3000 : 36 and 198.51.00/20. So you create a prefix list matching that. And now what happens here is, as I told you earlier itself, so in BGP, the best practice for V4 is like you have to accept a prefix length till /24. Okay, so for V6, you can accept till 48. So this is like, so now the peer is advertising a /36. Maybe in future, if they want to advertise a /42 or 48 or 46 or 40. So if you do a correct, if you do a prefix list and just match on this 36, so anything beyond that would be filtered out. So make sure that you create a prefix list with less than equal to 48. So now we have /37, 38, 39, 40, 41, 42, all the way till /48 from the peer. So other than that, you deny everything. So this is a clean inbound filter from the peer. From the transit, again, you have two cases from the transit, whether you want to receive a default route, meaning that you don't want the complete routing table. All you need to reach make sure that you need to reach the transit, because the transit has the complete routing table. Okay, in that particular case, you would receive a default route. So so you permit the default using the permit statement, and then you implement it on the neighbor, and clear the neighbor session so that only the default route is accepted. The rest of it is rejected. So this is when you want to receive a default route. When you want to receive the complete prefixes, internet prefixes, or the complete routes, you don't accept your prefix with the bogans and anything larger than /24 and 48. Other than that, you accept anything. So whatever the number of routes in the BGP table is, a global routing table is, your upstream or your transit would be sending to you. So make sure that you have enough routing capacity to handle that volume of prefixes. So this is how it works out. So you deny your prefix, your customer prefix, your both customer prefixes. You don't want this to be sent from your transit. Okay, and this is for V4 and V6, and you permit rest of it. So that is how it works out. You'll try to understand when we start doing the labs. So this is a long list of inbound filters from transit. These are the prefixes you would be filtering it out, and the ones in the blue are the ones will be allowed. So these shouldn't be seen in the global routing table. But if at all someone leaks and happens to reach your transit and the transit sends to you, you can prepare, you can make yourself with a good inbound filter so that you can reject all these unwanted prefixes, which shouldn't be seen in the global routing table. Okay, so again, from the transit, you can fix whether to accept anything with a /24 or anything greater. If you want to do traffic engineering, multi-homing or something like that, you might receive a /25 or 26. But it's highly recommended to keep it at a /24 boundary inbound. Okay, so that's your inbound filters for V4 and your V6 filters. So you want to filter out the documentation prefixes, unique local address, link local, all those reserved address box which you shouldn't be seeing inside the global routing table. So you don't want to accept that unwanted stuff to enter into your network. So, and again, you deny your own prefix. If someone is hijack your prefix and start sending to you through your transit, meaning that it's a hijack route, right? So you don't want to receive your prefix, and then you permit only the rest of the global unique as valid address space. Okay, so that is your inbound filters. So don't accept anything greater than /24s. Don't accept anything greater than /48. So that is how your filter works. Any question on the filters? Is it getting too much technical, boring? If you are not from a networking operator background, it might be a little bit boring because you don't see these things in your daily life. Any questions on the filters? Okay. Yeah, okay. I'll try to because if you're not implemented BGP or prefixless, it will be a little bit of problematic. So so that's your filters, because your first line of defense is your filter, because that's how it works out. So how do you get the filters? So one is like you do a whois. So you do a whois on a particular address space address, and now you get the particular who owns the address space and the details of that. So you have to cross check it before you, if it is your customer prefix, you have to cross check using whois and try to understand it. Otherwise, make sure that it is the right person announcing it, then do your filters, then accept the rules. You can do BGP Q3 and Q4. I'll show it as we progress. Once you start understanding prefix list, I will show you how these things are. So you can use BGP Q3, and I'll just show you that. Just a minute. Okay, fine. So I have BGP Q3. So I have BGP Q3, and I give AS 1075, which is fiber at home Bangladesh. So it creates an automatic filter for me. So earlier I created a prefix filter for my customers, right? So AS 1105 is fiber at home. So they have these many prefixes with them. So if I want to create a prefix list, I can just use BGP Q3, which automates the prefix filters. The problem here is with see, I said I was supposed to tell you that there are something called internet routing registries, where each route you create a route object for IPv4 and IPv6 if you are an operator. So there is something called RADB. So RADB is kind of a repo where it gets synced up, where you get it syncs up with lots of routing registry databases. The problem with RADB is like it is not always a source of truth. Sometimes you might see proxy, prefixes put into the RADB. So it's always better when you do BGP Q3 or something like that. It's always better to point to a source that is. So oh my God, sorry. So APNIC is the registry based up in for Asia Pacific. So I'm just comparing the prefixes that I received from RADB, and you can see 203 prefix. Actually is not owned by fiber at home. So it means that someone has done a proxy on that, and they have put that IS 1075 owns. So these kind of things are there. It's always better when you create a prefix filters, you point to a source, that is BGP. S stands for source, capital S stands for source. APNIC is a registry, regional internet registry for Asia Pacific. So point to the RIR, that is the authoritative registry, so and create a filters. And now you can see that only the 163 and 103 are the one prefixes which our AS 10075 holds. So these filters can be created and applied on your router, and you can apply for your to the BGP names. So that is one way of doing it. So these are examples of that. We'll get back to that once we. So okay, so we had. So we had IP address, Bogan IP address spaces, but just like your Bogan address spaces, you have Bogan ASs. But unfortunately for the Bogan address spaces, we couldn't list all because the numbers were too much. And for the Bogan ASs, you can see all those lists put up over here. So it's AS0 shouldn't be in your path, AS2456 shouldn't be in your path, a documentation AS shouldn't be in your path, a private AS shouldn't be in your path, reserved shouldn't be in your path. All this reserved and private ASs shouldn't be in your AS path. So it means that, let me just go back to the labs. Where is it? So I do show IPBGP, so I can see that a route is being learned from a 10.0.0 network is learned from 192.168.255.254, which is my next hop, which is in this particular case my transit. So it has been originated from an AS with the name 65001 and then passed on to traverse to 6500, and it got prepended twice. Actually, prepended meaning that you want to either make this AS longer, so it has manually been prepended. So that's the reason you see do AS number next to next, and you can see it has passed through. It has received what 64510. So this is the AS path. And when I say a bogan AS shouldn't be in the AS path, meaning that when I say these AS numbers shouldn't be in the list of bogan AS shouldn't be in the AS path. Don't worry about these are, in this lab, we might be violating all those rules because this is for learning purpose. So you might see 192.168, which is a reserved address space used in this lab. 10 is a prefix. Again, it's a private address space. You shouldn't be seeing in the internet. 172 is again a private address space. You shouldn't be seeing. But for the learning purpose, I can't take any prefix that Airtel or Vodafone holds it, right? So it becomes a violation. So from that particular case, they started using reserved fixes for learning purposes alone. Yes, you have any question, Mathur? Mohit? Any questions?
The screen is not shared.
Oh, sorry. Okay, fine. So you didn't see this, right? Hello? You didn't see this?
Yes, we can see.
Yeah, fine. So when I hit show IP BGP, I can see that a route 10.0.0 has been learned from a next stop of 192.168, 255.254. That is the next stop. The next stop happens to be a transit because this particular IP is the transit IP. So I'll show you that once you start discussing the lab topology. So a 10 series network is a private address space. 172 is a private address space. 192 is a private address space, which you shouldn't be seeing in the real world routing table, right? But this is for the learning labs. You can see all those unwanted stuffs are being used here. So AS path is like it says that the prefix 10 is advertised or announced or originated from 65001, and it has traversed through these many ASs to reach your AS. Okay, so the AS path, you shouldn't be seeing the reserved ASs which I listed over here. Okay, forget this example because in our case we use private address space just for the learning purpose. So keep in your mind these ASs shouldn't be in the AS path. So there are ways of tracking and notifying bogans. Team Kumri has provides you with free bogan fields. They have two AS numbers dedicated for this. Those are in the right corner: 65333 and 65232. So if you want to receive complete full bogans allocated plus the prefixes allocated to RIR and which are not assigned to any RIRs, then you can pair with 65332. It's not necessary that you need to be directly connected. You can do a eBGP multi-hop peering with the Team Kumri, and they would send you the list of full bogans or partial bogans based on which AS number you plan to pair with. So that's how you keep a track on it, because you can't manually track all those bogans. It has to be automated at some point of time. So Team Kumri does that part. All you need to do is just pair with them. So this is the filtering mechanism. It is, I think, to an extent clear. Is there any questions? If I need to answer or clarifications, I should do. Any questions? Any questions? Okay, next action is anti-spoofing, because it's based upon RFC 2827 and it's a best current practice 38. So source address validation is one of the best practices aimed at filtering packets based on IP address. Source IP addresses are the network entities. So this is like the source address space spoofing can be one of the main issues with DOS and DDoS attacks. So when you implement source address validation, you implement and filter invalid source addresses, and you implement filters that are close to the packet source of origin. So that's how we implement source address validation. So this is not related to BGP. This is related to your V4 and V6 address space. So spoofing is one of the biggest issues, or one of the cause for DOS and DDoS attacks. So there are two ways to mitigate it or stop spoofing. One is you can implement access control list. It creates an access control. You have to create a list for the customer IP blocks and implement it inbound, so that you filter out if the packets have been spoofed. And there is another way of doing it, URPF, which we'll be discussing in the next slides. There are 4 ways of doing it. One is loose and strict mode. In the next slides, we do that. So what it does is, like, say example, you have a router and you have 2 interfaces. One is gigabit Ethernet 0/0 and gigabit Ethernet 0/1. So if you have an IP packet sourced from 192.168.255.1, and it is received at the router through gigabit 0/0. The router would check after, if you implement the URPF strict mode, what it does is, like, it checks against the FIB, the forward information base table, or the CEF table in Cisco, and it looks whether this prefix or the packet received matches with the interface it is supposed to receive. So it is matching with the interface it is supposed to receive, so that so it passes the URPF check, so the packet is forwarded. Say example, if your packet, if the source of the packet is 203.0.113.1, is received at gigabit 0/0, but it is supposed to see from 0/1. So the URPF does a strict check on the received interface, and it sees that 203 shouldn't be received at this particular interface, and so it doesn't pass the URPF check, and so that the packet is dropped. So this is one of the. Can I admit them automatically? Okay. So this is a strict mode. Say example, you have a customer is connected to an operator network, and the operator is connected to the rest of the internet. So it's a stub customer. So it is just connected to one upstream provider. So all you need to do is URPF at the interface that is connecting towards the customer, that is gigabit 0/0. So you go to the interface in Cisco configuration, go to the interface 0/0 gigabit, and issue the command IP verify unicast source reachable via RX. RX stands for received interface. So this is for IPv4, and for IPv6, it's IPv6 verify unicast source reachable via RX. So for Juniper, it's go to the address family INET, do RPF check. If it is V6, go to INET 6 and do an RPF check. So this is the strict mode configurations. I'll show you in the labs how you do strict mode, and how do you stop your network from getting any spoofed address space. So this is possible if your customer is connected to one upstream provider server, meaning that it's a stub single home customer. Okay, so if it is like multi-home meaning that if your customer is connected to multiple service providers, then the strict mode won't work out, because it checks with the FIB table and checks whether the IP address or the source packet received matches with the incoming interface. So if it is multi-home, it might take one path and the packet comes to another path. So strict mode doesn't work well. So you can do URPF loose mode, where you go under the interface, and instead of reachable via RX, you issue the command any. Okay, so loose modes is recommended for multi-home networks where you will be connected to multiple service providers. Say example, I'll show you what is multi-home. So if it is connected to multiple service providers, it is called multi-home. So in that particular case, if you still want to implement URPF, you can do it, but it works fine if you are single home, meaning that you're connected to one service provider. If you don't have the capacity to run URPF, URPF runs in most of the routing platforms like Cisco, Juniper, Alcatel, Nokia, Service Router, Microtech, anything, any Arista, everything. So if you're running older versions of routers, then the only option is for you is to implement access list. So what you do is like you implement access list on the interface that is connected to the customer. Other customer facing interface, what you do is like you create an access list, you match the prefix of what the customer is going to send you, you permit it and you deny the rest, and you implement it on the interface that is connected towards the customer. So that is one way of doing it. That's an access list configuration. Most of the networks in India do that, at least. Since anti-spoofing technique in action in MANRS is not a mandatory, we cannot expect everyone to implement URPF. But when compared to URPF, access list is a little bit tricky, because if a customer is changing, is being allocated with a different prefix, again, you have to manually updating it. So you have to keep a track on what the customer is announcing, and based on which you have to edit the access list. So if you do a URPF check, there's nothing like your address space, right? All it checks is like the source address has to match with the incoming interface. So this can be used for in cases where a dynamic allocation of address is there to the customers. So that's the what you call anti-spoofing. So any questions on anti-spoofing? Any questions on anti-spoofing? Any questions on anti-spoofing? Okay, then we go to the third action, which is coordination, which is very important in case, because it's just action 3 of MANRS, and we expect the network operators to maintain a globally accessible, up-to-date contact information, because that's what, if I am a network operator and I have a question. Yeah, we cannot avoid anti-spoofing, but we can stop anti-spoofing, because spoofing is someone purposefully doing it, right? So for launching DOS attack or DDoS attack, the intentions are very simple. They just want to harm you. They don't want to steal anything. That's the reason they do anti-spoofing. They do spoofing. To stop it, you can implement anti-spoofing measures like implementing access list or URPF on the network edges. So I'm talking about the network edges, not on the server side. That is a different story. So keep in your mind that you cannot stop it because someone is doing it intentionally, because spamming is done intentionally. And if their intention is to steal something, they would have hijacked the prefix. That's what they do normally. So spoofing is just to knock you out of the network or the internet. The coordination portion is very important, because if some incident occurs, you want to prevent or mitigate it, some routing incidents, then you have to have an effective communication in the network operators world. So communication is mandatory. So coordination is mandatory as well. So up-to-date databases has to be, a contact list has to be in the databases. You have to update at the internet routing registries, the WHOIS database, the IRR, peering DB, etc., etc. Even if you have, the contact information is recommended on the company website as well, because if there are non-technical persons trying to reach out saying that you are sending some unwanted stuff to my network, at least they don't know how to do WHOIS or IRR or check in peering DB. So it is, you maintain almost up-to-date information, so that if you're part of an incident or you are a victim as such, then at least someone can reach out to you to help. Question? Provides access to prefixes only and just my. You don't need to worry about it. If you have filters, it's safe. If you don't have filters, then that's the problem. See, because in the earlier cases, you didn't have any filters. That's the reason we recommend you to have either an access list or URPF. So URPF is recommended by the MANRS community, but again, you can't expect to run it on all networks, like maybe because of the version of the network operating system you run on the devices. So this is how you update on BNDB. This is Fiber at Home Bangladesh. So they have NOC team, policy team, technical team, etc., etc., etc. The contact phone numbers, emails, names. Yeah. So if you do who is on that AS 1005, I mean 1000, I mean 10075, you can get the information as well. So there are MANRS participant as well. So plus our MANRS ambassador happens to be working with Fiber at Home. Most of the examples are taken from them. So these three of the three actions, one is filtering. Filtering is your first line of defense, as I told you. Lots of stuff has been discussed on the filtering. Then we had some discussion about anti-spoofing. Then we had some updations on coordination. Let's go to, let me just turn on my charger. Let me just grab some water as well. Hello. Okay, so the fourth action is the validation, which facilitates validation of routing information on a global scale. So there are two ways of doing it. One is validate with the IRR or the RPKI. So Internet Routing Registry contains information submitted and maintained by the providers and the other entities, just like the AS numbers, routing prefixes, etc., etc. So IRRs can be used by the providers to develop routing plans. And there are other ways of doing it using RPK as well. So I'll just show you if you go to bgp.he.net, you can see. So this I'm connected over Airtel. So if I click on V4 prefixes, you can see that there are I have a prefix 27.56.128.0/20. And you can see that it's an IRR valid, okay, and it's an RPK validated, signed and ROVA signed and validated. So this is a validated route. So IRR Internet Routing Registry, the network operators can document which AS is originating a prefix V4 and V6. So earlier in my, I showed you in BGP Q3, all I did is like, I did a BGP Q3 and generated a prefix for AS 10075, which happens to be Fiber at Home. So I didn't do anything else other than that. But once I queried for it, I got the list of prefixes which AS 10075 holds. So this has been documented properly so that whenever I try to generate filters, I can fetch that filters which is being mirrored from Internet Routing Registries. So the problem with it, as I told you earlier itself, there is something called RADB, which is RADB is like routing database, which is the problem with the RADB is like there are lots of proxies and lots of junk stuffs over there. So when you don't do any source based, if you don't point to a particular source of truth, what happens is like you might get some unwanted prefixes into the filters as well. So it's always better to point out to a particular registry or some regional registry to generate your filters. Because all you need to do in RADB is like you get a commercial membership with them, a relationship with them, then I just edit something. I can create a prefix which Airtel holds and go to RIDB and create a proxy for that. So it is a little bit rubbish. So when you try to generate filters, it's always better to go and point out to a particular source, that is the registry. So that is IRR, which is done by almost everyone. So then the next thing, how do you validate it? So RPKI is one of the ways for validating it. So resource public key infrastructure. So what it does is like it stores information about prefixes originated from your network in the form of something called the ROA, root origin authorization. So only the prefixes that belong to your prefix is covered actually. So only the origin AS path is verified. So what it does is like if I have a prefix, say example, if I have a prefix like this, this is again a fiber at home Bangladesh, AS10075 is owning a prefix of 103.229.82.0/20. Okay, so this is a prefix fiber at home owns. And if I create a rover for this, then I say that I have a max length of /24. It means that any prefix that is having a length of in this particular range of 103 till from /23 to 24 is valid. And this particular ASN is the right person to originate it, is the authority to originate it. Say example, if I own AS number 100 and I originate the prefix, which is 103.229.82.0, what happens is like if they have done a root origin authorization and validated it, if the particular prefix, both the prefixes is received from received data provider, they would check into whether this particular prefix is a valid against the validator. Then if it passes the check, it is the root is accepted. Other than that, it is either filtered or dropped. So that is what ROA does in simple words. So what RPKI can do is like it can legitimate, it can point out who the legitimate owner of an IP address is. So it does two things. One is like whether you are the right person to authorize, announce it, and the prefix length and the prefix. Three things it does. Look into it. One is the prefix, the length of the prefix, and the origin is. That's what RO does. Okay, fine. So this can be used to prevent hijacks and misconfigurations and misorigination. So in most of the cases, if you take the routing incidents in the examples I showed in the earlier slides, you can see that it is either the wrong AS that has been announcing the prefix, or it is the prefix length that is, that has been announced in the from different ASs. So if you do a RPK validation, RPK-based validation, this kind of hijacks and misoriginations can be prevented. So it works on something based on X.509 certificate. So there are three states of RPK. One is valid, invalid, and not found. So whenever you create a ROA and the root is validated, it can be in three states. Whether it's if it is a valid state, then the prefix length and the AS pair should be matching in the database. Okay. So if it is an invalid, then the prefix is found, but the originating AS is it's the wrong AS originating. Or it can be a valid if the prefix length is longer than the max length. In the earlier example, I said if it is /24, I'm doing it. Imagine it's a /23, I'm putting the max length. And some say example, I'm originating 103.229.0.0/24, which is a /24 from that block. So, but the max length is saying that I can do only till 23. Then if I advertise as /24, it means that the prefix is hijacked. So it shows an invalid. Okay, even if your AS is advertising /24 also, it would become an invalid, because the max length. If you want to advertise /24, you have to change the max the MSA, the more specific advertisement, to /24s. So those are the cases where you have invalid, and not found. So not found is the case where you haven't created any ROAs for your prefixes. So it cannot be categorized as a valid or invalid. So In most of the cases, it's not created at all. So an IP prefix V4 or V6 can be a valid, invalid, or not found. So in the normal case nowadays, it's like more invalid. I mean, more not found, because most of the networks haven't implemented ROA so far. And if it is wrong AS number originating a particular prefix, then it becomes an invalid. And if it is violating the max length longer than the ones you have, longer than the ones you created by creating the ROA, and it becomes an invalid. So these are the three states of RPKI. So there are many ways. So you can create ROAs. There are validators which can be used to validate the routes. So I don't know whether if you are not running networks, it's you don't need to test it. So you can have and go to the MANRS how-to videos. You can see Dr. RPK, Router, photo validator, etc., etc. These are the validators you use for as a relying party. So in Epinic, you can go under the My Epinic and go to the resource certification and create ROAs. Click on the RPKI, create route, then add your prefix, your origin AS number. MSA is what I told you, the max length, which is more specific announcement or advertisement. A /48 is what you put, and just click on ROA enable next and submit it. That's what, it's easy. That is what you're supposed to do. If you have my Epinic account and if you're running networks, that's the point here. So after you implement ROA, what happens is like you advertise a prefix. So you have a ROA, valid ROA, and say example that is your network, right? So in the top, that is 178.2.1 is advertising a prefix 204.06:6400:48. So it is traversing and reaching to your network. And you have two routes. You have a single route from two different AS paths. So one is having a shorter AS path. So BGP, what BGP does is like it would, in the normal case, it would accept the ones in the bottom that is received from through AS 65553 because it has the shortest AS path. Now the problem is this is the original announcement or the legitimate owner of the address space. So if you implement root origin validation, what it does is like once you receive the prefix and now you connect to the validator, the router talks to the validator using a protocol called RTR, which is RPKI to router protocol. But the validator software is what I told you earlier, like Okta RPKI or Fort or Routinator. Then it syncs up with the rest of the global repo, which is run by the different regional internet registries and national registries. Now, whatever ROAs you have created would be in the global repository. Whenever you get a prefix, it would check against the validator and check whether the prefix is a valid, invalid, or not found. Okay, in this particular case, you receive a prefix with a length that is, with a prefix of 204.06:6400:48, which is the valid, and it is validated in ROA. So now you receive this prefix as well as the source, and the source AS number as well. So it checks against the ROA. Now ROA has been created for this particular prefix with the length till 48, and the originating AS is 178.2.1. So this is the ROA that is created. Now the router checks with the validator, so which syncs up with the global repo using rsync or RRDP. So that is a protocol that is used for syncing with the global repo. Now it checks the repo and finds that the prefix 2406 has a ROA created, with the origin AS of 178.2.1. Okay. So now the two prefixes arrive at the router. Now you see it checks for the ROA, and it understands that the route that is originated from 178.2.1 is the legitimate one, and it's the valid one, and it accepts it. And it checks for the other route, which is 555.2, which is invalid in this particular case because it's not matching with the ROA that is created. So it is marked as invalid. So most of the service providers nowadays have implemented a policy that they wouldn't accept invalids because RPK has been in the system at least from 2012 onwards. Most of the network operators started implementing it. Nowadays, last year onwards, most of the tier 1 providers started dropping invalids. So there's that particular route would be dropped. This is how the route hijack or leakages is stopped. So if you do whois for a particular address space, so you can see that this is again a fiber at home. The prefix 2403 colon CD940 colon/32. You can see that it's a valid prefix. So that can be checked before using whois as well. So on the router configuration, which you can check because these are pretty straightforward. These are like route-based routers where you can check whether, show IP, BGP, RPK servers. So you can see that the server is connected to this IP address and the port and the TCP port through which it is connected. So RPK server meaning that it's the RPK validator. Okay. This validator. So I'm checking the session from this router to here. So when I search for RPK servers, it shows the validator and the IP address through which I have connected and the TCP port that is through which I established the connection. So these are configurations, you can look into it. And so this is root server with AT&T, which is running Juniper. So if I do a show a validation session detail, I can see the details of it. So this is a Cisco configuration. So I think BGP RPK servers is a Cisco, and this is Juniper. And excuse me. So if I hit the command show validation session, it shows that there are 2 validators. So it's always recommended to run multiple instances of validators because to maintain failovers. And so that is what it is showing. And if I go to the route again and hit the command show BGP IPv4 unicast, that would show you the list of prefixes which are valid or invalid. So most of the cases, if you take Hello, am I audible?
Yes, sir, you are audible.
Yeah, someone muted me.
By
Okay.
mistake.
Yeah, fine. So that is for the V4 table. So for V6 table, it is you can see show BGP IPv6 unicast RPK table. You can see the RPK table for your V6 routes. So most of it, you can see the max length, which I told you, the originating is the max length. So say example, if I have a prefix of 2001 colon 200 colon /32, and the max length that they have created over is a 32/32. The origin AS is 2500. Now what happens is, like, if I advertise this prefix with a /36, what happens is, like, even the same origin AS 2500 originates its route with a /36. In the RPK table, it becomes an invalid because the max length has to match. So if I want to originate a /36, I have to increase the max length to 36 or anything greater than that. So these are things which the guys who implement RPK know well. If at all you miss it out, you might have to clean it up because otherwise your network won't be reachable the rest of the world. So if I take a particular prefix and do a check against the BGP in my BGP table, so this is the prefix 27.56.128.0/20. I think this is with Vodafone itself. So this is this is a RPK valid. It has been validated. I can see the state is valid. So again, 59.144.173.0/24, it's an invalid. So how did I check it? So I went to I take this one and check against the in the BGP table. My God, but unfortunately I don't have access to University of Oregon's network now. So I can just use the command show BGP IPv4 unicast and the address which I see, which is invalid. I can check against it, or I can do a who is. In that earlier example I showed you, can do a who is -h who is .bgp.mon. Open quotes space double dash rover the origin is and the prefix. So it shows whether it's a valid or invalid. Okay, so that is what you can do. But this is for your learning purpose. You can do that. But routers would look into the what you call the local cache of the validator, which happens to be installed in your network or somewhere else. So for your learning purpose or trying to understand it, you can just look against the table. If someone is dropping you because you are an invalid, you can just check into it and try to fix it out. So this is not found for a prefix, that is 122.64.200.0/. So most of the routing vendors and open source platforms do support root origin or validation. So you can see Cisco iOS, Juniper, Nokia, Huawei, FRA, Bird, etc. goes out. So that's it. So this is what as of June, because I'm sorry I didn't update it. I think it's not June, actually it's August itself. Around 573 network operators have joined the MANRS program, have implemented it, are at least not part of any routing incidents. 91 exchange points, 17 content delivery networks, and research and education networks. These are the list. So okay, these are the list of CDNs who have joined the cloud program, and so Akamai, AWS, Cloudflare, Google, Microsoft, all the big ones are into this because they don't want to get hijacked or be part of any routing incidents. So this is a long story short of the MANRS activity. So if you are from a non-technical background, it will be a little bit of too heaviness on the technical. So do you have any questions so that I can show you the labs? Any questions? Any questions? If you don't have any questions, then we can start doing the labs. Is it fine with you guys, or do you want a 5 minutes break? Or how does it work? It might take another hour, maybe an hour more. So how do you want to take it? A 5 minutes break, or should we start? For the ISP, it is mandatory. It is mandatory for ISP. Yes. For the ISP, see, this is like that is what operator is called because if you are I can tell you examples of small ISPs which are localized to a particular city. Then they can ask their upstream to do it because if they are too small, they can ask their upstreams to do it. And if you are a class B in India, then you can do it yourself. That's what it is better to do it. If you're an enterprise, you don't need to do MANRS actually. So this is purely for the ISP world actually, to be frank. ISP and Internet Exchange Point and cloud and content providers. For the enterprise, what you can ask is like you can ask your provider to do the anti-spoofing, filtering, because your routes are not hijacked from someone is not hijacking your routes, someone is not leaking your routes, those kind of things. So around 2000 ASs are there in India. I think maybe like 20 to 30 ISPs in India should be enough to reduce the incidents, the top ones at least. Because they provide the connectivities to the rest of the world, right? So if they implement proper filtering and RPK validation, then the smaller ones won't be able to create much issues. And yes, how do we take it forward? Should I show the demo, or do you guys plan to do with me? I don't know. how does it work? So which is better? Should I show the demo or you guys listen to it? Okay. Okay, great.
Naveen, do you need a break because you've been continuously talking for 2 hours?
Yeah, I've been talking for, yeah, maybe 5 minutes should do fine. Yeah.
Yeah.
We'll break for 5 minutes. Let me.
So participants, would you like to do the lab on your own or you want a demo so that you can arrange accordingly?